Hello, chemistry. Today we're going to do a practice problem using an actual chemical equation that's balanced. So, no more cheeseburgers. And here we have an equation. I'm going to zoom in a little, see if that helps. Okay, so we have butane, which is going to react with oxygen to produce carbon dioxide and water. So if you notice, I have balanced an equation up here, or I made sure the equation is balanced. And so you always have to start with a balanced equation. And the question is, how many moles of CO2 are produced from 27.6 moles of butane? So first step, what are you starting with? 27.6 moles butane. And I'm going to have you guys write out the formula for butane. Don't skip this step. Don't skip writing this, like the actual chemical that you're talking about, because that's going to be important later on. And I'm going to be going to moles of CO2. That's what I want to know the answer to. So I have to multiply this by something, and again I'm going to put it over 1. And in here, this comes from my balanced equation. So on the bottom, it's going to be mole of butane, C4H10. And the top is what I'm looking for, mole CO2. I then look up here, balanced equation. And for the CO2, I'm going to put the 8. I get that right here. And for the C4H10, I look over here, and it's going to be a 2. So don't worry about reducing that fraction in the middle. Just leave it like that for ease. You're going to get your calculator, and you're going to put in 27.6. Can you guys see that? I don't know if you can see that or not. 27.6, and I'm going to multiply it by 8 and divide it by 2. Times 8 divided by 2, and it's going to be 110.4. So if I have 110.4. So if I start off with 27.6 moles of butane, I can produce, or I will produce, 110.4 moles of CO2, carbon dioxide. So if I have all this, the next question would be how many moles of oxygen are needed then? So it's assuming that you're going to use all 27.6 moles of butane, and we know that the end result is going to be 110.4 moles of carbon dioxide. So how many moles of oxygen are needed? Again, you could actually start with 110.4 moles of CO2 or 27.6 moles of C4H10 butane, and you'll get the same answer, but we'll start with what's given. 27, in case we made a mistake up here, you never know. 27.6 moles C4H10, and my roadmap is how many moles of oxygen, so many mole of O2. And again, I'm going to multiply it by something, and this box is the ratio that I have to get from my balanced equation. I'm going to put mole C, I better erase that one, hold on. Mole C4H10 down here. I'm looking for mole O2 up top. Look back up here. So you'll notice it's still the 2 is on with the C4H10. And I look up here for my O2, 13. So then again, I take my calculator, 27.6, multiply it by 13, divide by 2. And I didn't do this up here, but I really should have canceled that out. So then I'm left with that. So I'm going to do that here. And so 27.6 times 13 divided by 2. And I get 179.4 mole of O2. 179.4 moles of O2. So if you have any questions, I would encourage you to re-watch this video. And I know that I've posted some other things online for you to use, but you can also research on your own mole ratios. And again, we're just going mole to mole right now. Next week we will take it a step further. So it's really good that you practice doing multimole. So I did post another assignment that incorporates these type of problems. So I would like you to do that. Okay, you guys have a great day, and we will be talking later. Bye.